Hello everyone, I am Ashwini from Department of Electronics and Communication Engineering from Rajiv Gandhi University of Knowledge and Technologies, Basar. I would like to thank Emertxe Information Technology for providing this internship. Now, I am going to share my experience and the things that I have learned from this internship. I am presenting in this video. So, I'll get started. Yeah. Our project is microcontroller based washing machine simulation using PIC16F877A. Here we can see the interface and we are going to simulate the washing machine in this PIC16F877A. It shows the interface of the PIC16F877A. Let's getting into the second slide. Yeah. Overview and goals of the internship. Coming into the overview, this project focuses on simulating a washing machine using PIC16Lab. Here, PIC16Lab is an online board for the simulation. For this washing machine simulation, we are using this PIC16Lab. This is to replicate the real world environment, real world washing machine environment in the virtual environment. And the second thing is that the project begins with a comprehensive understanding of washing machine components. Here, the components means the software, hardware, and the mechanical parts that are included in the manufacturing of a washing machine, the cycles and operations. And the third thing is parameters. Parameters defining laundry status such as fabric type. Here, the fabric type is the type of the cloth that we are using. Load size means the quantity of cloth we are using, and the water level are identified here. And thus, this simulation project provides valuable insights into washing machine operations, control system design, and simulation techniques. So that by this, we can gain practical experience in applying algorithms to simulate intelligent appliances, contributing to a better understanding of laundry automation. Going to the next one, the contents. You can see the contents of the internship over here. This is the embedded C. In the embedded C, I learned keywords, data types, conditional statements, operators, data structures like arrays, functions, pointers, macros, etc. In microcontroller, that is PIC16F877A, I learned the architecture, that is pins, input and output pins, timers and interrupts. And coming to the hardware in Pixim Lab, I learned some peripheral devices like a CLC display, fan, buzzer, LCDs, etc. Now, at the end of the video, we'll discuss the washing machine simulation using this Pixim Lab, that is the hardware. Coming to the next one, introduction. Yeah, in the introduction, washing machine has become an integral part of human beings in order to perform their daily course of washing clothes. Over the course of time, with the advancement in the technologies, different types of washing machines have come up in the embedded systems. Means during the earlier days, we used to have the washing machines which are only given the functionality of washing the clothes. But coming to nowadays, we are getting the washing machines which washes the clothes and which also dries up the cloth. Yeah. This is the advancement in the technologies day by day. Through this, we try to show the light over the systems of washing machines and its working with few additional features. And then going into the next slide, yeah, embedded systems. Yeah, that's fine. That till we are listen that we are into the in project of embedded systems given by the Emertxe technologies. But what is embedded systems? Yes, that is embedded system. An embedded system is a computer-based system. Means it is the embedded system is a simple, not a simple one. It is the complex one. Means it is the combination of two or more parts. That is, it is a combination of a computer processor, computer memory, and input-output peripheral devices that has a dedicated function within a larger mechanical or electronic system. It is embedded as a part of complete device, often including electrical or electronic hardware and mechanical parts. In embedded system, we also have a embedded C. Embedded C is used to perform a wide range of Embedded C is used to perform a wide range of microcontrollers and microprocessors. Embedded C requires large number of resources to execute in comparison with high-level languages such as assembly programming languages. Yeah, this is the description of the embedded system. So going into the next one, that is classification of embedded systems. Means the types of embedded systems we are having that the embedded systems. Yeah, the embedded systems are broadly classified into two types, that is, based on the performance and functional requirements, and based on the performance of microcontrollers. Coming into the based on performance and functional requirements, embedded systems are classified into four types, that is, real time, standalone, networked, and mobile. Yeah, that real time embedded systems means the real time embedded systems are designed to perform a specific task within a time frame. Then the standalone embedded systems. Standalone embedded systems work by receiving the input without using any ghost system for desired output. Means we don't have any desired output for the standalone embedded systems. Coming into the third one, the networked embedded systems. These are usually general purpose processors, nothing but the processor. Then coming into the fourth one and the last is the mobile embedded systems. These are embedded in the mobile phones and cameras and etc. and many more places as well. Then going into the embedded systems based on the performance of microcontroller, they are classified into three types. That is, the first thing is the small scale, the next one is medium scale, and the last one is the complex. Getting into the next slide, that is keywords in C. Yeah. As we all know that there are 32 keywords in the C language. Keywords in C are the reserved words that have predefined meaning and are a part of the C language syntax. These keywords cannot be used as a variable names. 32 keywords are present in the C language. The keywords are auto, desk, case, break, care, continue, do, default. Yeah, we represented all the keywords over here in this table. You can check it for the reference. Then getting into the next slide, that is data types. Yeah, what are the data types? Yeah, you can know that a data type is an attribute associated with data that tells a computer system how to interpret its value. Understanding data types ensures that data is collected in the preferred format and the value of each property is as expected. Yeah, and we can represent the data types in three ways. That is, the data can be represented as numbers, data can be represented as characters, and data can be represented as strings. Yeah, we know that strings are nothing but the collection of characters. Here ends the operators. Now let's go to the next slide. Yeah. Coming into the conditional statements in C. Computer program needs to make decision. So whatever anything that need to make decisions over its function and program. So we use conditional statements in programming to test whether or not something is true. We have types of conditional statements in the C. The types of conditional statements are if statement, if else statement, if else if ladder, nested if else statement, switch statement. Yeah. Coming into the if statement, if the condition is true, then the code in the block get executed. In the if else case, if the condition is true, this block will get executed, else this block of code will get executed. And if else if ladder and switch, these both are almost same, but when there are more statements, we go for the switch. Yeah, it always based on the programmer, any statement can be used, but the function is same almost. That is, if the condition is true, then the code will get executed. If not, it will not be executed. That's it. This is the description of conditional statements. Then get into the next slide. The main heart of a washing machine simulation is this microcontroller. Yeah, this microcontroller is PIC16F877A. What is it? Yeah, what does PIC? What does PIC stands for here? Yeah, the PIC is the peripheral interface controller. Yeah, this PIC16F877A. It was developed in 1975. It has a 16-bit code and created to handle the input or output tasks of the larger central processing units to improve overall system performance. PIC is one of the peripheral interface controllers which is popular starting from the beginners until all the professionals. Getting into the features of this microcontroller, yeah, it has three timers. We know that the timer 0, timer 1 and timer 2. These are three timers of this microcontroller. And the second one is high performance. It has high performance because its CPU is RISC. We are getting here the word RISC. What does the RISC mean? And what it stands for? RISC stands for Reduced Instructions Computer. Getting into the third feature, that is, the instruction set is very less. That is, it has 200 nanoseconds. So that's why the performance is very high. And the fourth one is CMOS technology. It is manufactured based on the CMOS technology, and it has 40 pins. We represented this microcontroller pictographically here. It has 40 pins on either side. I means 20 pins on either side. 20 pins on either sides of the microcontroller. We can see the 20 pins over here. This PIC16F877A. It is manufactured by Microchip company. Yeah. These are the details of this microcontroller. Then going into the next slide. Yeah, we can see the pin diagram of this microcontroller over here. This is also represented in pictographical model. Yeah, we can see those 40 pins over here. We also specified each pin's specific operation here. Based on the common point over these operations, these pins are categorized as ports. Mainly we have five ports in this microcontroller. Those are port A, port B, port C, port D, and port E. Don't get confused that there are more ports here. Port C and port D are represented on either sides, based by the efficiency of these pins over here, represented over here. Yeah. Port A. From pin 2 to pin 7, these comes under port A. And coming to the port B, from 33rd pin to 40th pin, those pins comes under port B. Coming to the last port E, 8th pin to 10th pin means 8, 9, 10 pins are of a port E pins. Yeah. Now let's get into the next slide. Those are interrupts. What are interrupts mainly? Interrupts play an important role in microcontroller. What are these interrupts? As the name suggests, interrupts are special events that require immediate action. It stops a microcontroller from the running task and serves a special task known as interrupt service routine, ISR. ISR stands for interrupt service routine. Now, these interrupts are generated from a source. Every point has a source, and interrupt has generated from the source. Interrupt has two sources. The first one is external source, and the second one is internal source. Mainly, these interrupts are classified into two types. The first one is maskable. Maskable means this can be avoided, and the second one is non-maskable means this cannot be avoided in any case. Here is the description of the interrupts. Now, get into the next slide. It is a method we can delay the process of going into ISR if required. Here, ISR stands for interrupt service routine. Now, get into the next slide. CLCD. What does CLCD stands for? CLCD stands for Character Liquid Crystal Display. Generally, we all know what is LCD, but what is CLCD? CLCD is a dot matrix liquid crystal display. It can be configured to drive a dot matrix liquid crystal display under the control of 4 or 8-bit microcontroller. And in this CLCD, many pins are available. We can see some of the pins over here. That is VSS. VSS for negative supply, that is ground in general terms, and VDD. VDD is positive supply, that is voltage given as input. And V0. V0 stands for contrast to voltage, contrast control. And RS. RS for register selected means if 1 is selected, that is for data, and if 0 is selected, that is for instruction. And read enable. RE for read enable. RW. RW stands for read or write. A means if 0 is selected, that's for write, and if 1 is selected, that's for read. And addressing in 16 cross 4 LCD display is done through rows and column addresses. Means CLCD is displayed in 16 cross 4. Here 16 indicates rows and 4 indicates the column addresses. Yeah. Now getting into our next slide, that is software effect. Yeah. In the simulation of washing machine, we used some softwares. These softwares play an important role in the simulation of washing machine. And many other softwares are used, but some of the main softwares here are all the softwares are optional, but these are mainly used over here. Those are MPLab X IDE, PIC16F877A, and X8 compiler. Coming to the first one, MPLab X IDE. What does it do? MPLab is a free software that is developed by Microchip company, and for the development of embedded applications, and it is called IDE, and IDE stands for Integrated Development Environment. Means MPLab X IDE is a free integrated toolset for the development of embedded applications on Microchip PIC and DSPIC microcontrollers. It is called Integrated Development Environment or IDE because it provides a single integrated environment to develop code for embedded microcontrollers. Over here, we can see the logo of the MPLabX IDE. Now, going for the next software, the second one is the PICSIMLab. With integrated MPLabX, PICSIMLab supports some PICSIM microcontrollers. Yeah, here we can see the pictorial representation. It is the interface of the PICSIMLab. Now the third one is the X8 compiler. The X8C compiler is a freestanding ISO C90 compiler that supports all 8-bit PIC MCUs. Means it supports every 8-bit PIC MCU microcontroller units. We can see over here the logo of X8 compiler. Now let's get into it. Now let's go. What is the purpose to do the simulation in this PICSIMLab? And answer is, this project focuses on simulating of washing machine using PICSIMLab. Means aiming us to replicate the real world washing machine functionality in the virtual environment. It refers to creating a machine in virtual environment. What is the virtual environment here? Here, the virtual environment we are using is the PICSIMLab. Now, we'll get into the PICSIMLab, how the project is simulated and how we replicated the washing machine of real world in the virtual environment PICSIMLab. Now, let's go into that. This is the overview of the PICSIMLab. This is the interference. Here we can see some peripheral devices like this is the fan, this is the buzzer, these are the switches, these are LEDs, this is the controller. And we can see the LCD display. We can set the LCD as we can set this LCD as 6x4 or 16x2. We can say the frequency of the board. For your reference, I am opening it for you. Crystal oscillator 16.4 I am setting it to 20 Hz. Firstly, opening the PICSIMLab, we have to select the board. I am selecting the PIC Genius. Then, where is it? PIC Genius. Yeah. Then, I am selecting the microcontroller PIC16F8. I am selecting microcontroller. Now I am loading my X file, which was compiled in MPLAB X IDE. Wait, load. Yeah, this is my project file. Go back. Yeah, I'm loading the file. Now press key 5 to power on washing machine. Actually, these are switches. Switch 1, switch 1, switch 2, switch 3, switch 4, switch 5. Now I'm pressing switch 5. Yes, the LCD displayed powering on washing machine and washing programs are displayed. We can navigate these by switch 4. I'm selecting daily to select daily. I'm selecting daily to select daily. We have to long press the switch 4. I'm long pressing it. Yeah, we jumped into water level screen. In that, we can see auto, low, medium. By using switch 4, I'm navigating to others. Yeah, I'm selecting auto. For selecting auto, as before, long press the switch 4. I'm long pressing switch 4. Yeah, press switch 5 to start, switch 6 to stop. Then I want to start, so I'm pressing switch 5. Yeah, we can see the function. You can see the function is wash. Time running is displayed. It is displayed. The time running is downwards, and that is the to pressing the switch. It will pass the function. The motor has stopped. The program also stopped. To continue this operation, I have to press switch 5. Yeah, you can see that. Yeah, I forgot to discuss these things before. The switch 1 button is used as door. If I press it, the door is open. If I release it, the door will close. As per the real-time washing machines, if the door is open, the drum will stop. The time to stop, everything should be stopped. When I close the door, then only it should restart. For that, we'll make, and the buzzer should be, yeah, I'm pressing switch 5 to start. We can see the door open, please close, and we can listen the buzzer sound. When again, I'm pressing switch 5, door open, please close, and we can listen the buzzer sound. When I release the switch, the fan starts, function rings, time start. Now you can see that by the decrease in the time, we can see the change in function. After completion of this time, the clothes get washed. The function is over, and we get a buzzer or a message to remove the cloths. Yeah, program completed. Remove cloths. This is our project. This is the embedded system project. It is similar to the real-time washing machine. Now we'll get it in the code. Now I'm opening the code. This is my main file. Yeah, there it is. You can see that in my main file I included some header files like digital keypad, timers, CLCD. And this is my initialization block which I initialized. Initially fan should be 0, should be off, like that. And this is my main block. In that when I open the fixing lab, wait, I am resetting it. Press, yeah, we can see that. Press key 5 to power on washing machine. This I have to print on main. In main, I am printing this. While switch 5 is pressed, I have to power on the screen. This power this power on screen, where it is. Yeah, here we can wait. We can power, yeah, power on the screen. Then power on screen. Yeah, we got. Here we wrote function code. We wrote a delay and we print a line of blocks and powering on the washing machine block, and you left some 1 second and clear screen. After that, what we'll do, after powering on the screen, we are getting into the main block. Means means after that supply, I have to choose what is the program, what are the clause, what is the water level, the program start to close. Yeah. If key equal to read digital keypad state means the key stores the value of the switches which I have pressed. If key Yeah, if key double equal to long press, what I have said that if we long press, the option will be selected. If short press switch 4, we will navigate. Yeah, I'm printing this. This CLCD printing is used to print the statements. Print the switch as it is printed on the LCD screen with line number and position. Means first line and how many columns. First line and columns. Next, I'm getting into the switch case. I'm selecting operation mode is washing program. What I have to do? Water level. As we seen, washing. We select washing program. Next water level. Next is start or stop screen. If case 1 washing program, I'm going to, yeah, calling the washing program function. Here I written the block of code. If reset mode double equal to washing program, display reset. Then clearing the screen, and we wrote here this washing program we written an array. Here we can see that washing program we written an array and stored all these 12 values. These are the 12 values: dairy, heavy, delicate, eco cotton, full hands, and many other. Here are 12 values. These are the types of cloths that stored in the washing program array. Auto, low, high, medium are stored in water level options based on the washing program we have selected. Next, after that, we went to the water level display. When it will go to the water level program, when I select washing program, then only it will go to the water level reset, means long press. Yeah, I wrote here CLCD and some functions like less than or etc. Means array 0, array of 1, array of 2. Based on the index value, the data will be printed. The data will be printed. Next, I am getting into the set time. Actually, when we go here, yeah, we got into PIC16F board. Wait, I'll start it again. I'm long pressing the select daily, then only it will jump into water level. Here what will happen? The reset mode is getting the water level. Now if we auto long press the reset, then it's getting to this mode is getting to pre-switch. Now I'm getting switch 5 to start. Here how we are getting 41 seconds? Because we wrote it here. We wrote here. We can see that in program number index 1, water level index 0. Here the seconds is 41 seconds. Based on these conditions, we display the condition. How we standard manual. Based on the standard value, we are taking the values. And these are all the values. Next, I'm writing the run program. I'm checking whether the door status is open or closed. If open, the motor should not run. If open, the motor should not run. The alarm should be on. The timer should be off. I'm checking the door status. And I wrote the code of run program. To rinse, we see the function is changing to rinse wash based on this only. Here we converted the integer to ASIC value because we should not write a integer value here. And for the door status, I wrote the code here, and this is the code. Now we'll see the main header file. This is my main header file. I defined some macros like buzzer, direction, fan DGR, some macros I defined here. Next digital keypad, some that macros, CLCD header file. Next this is the interrupt service routine file. Because I'm getting into the interrupt to some main programs, that's why I used this file. Next CLCD, this file. Next digital keypad. In this I selected how much the long press is detected here. If the long press is greater than 30, sorry, if the long press is 30, then only it returns to the pre-key value. If the button was selected, if next we wrote the timer. This is the main file. How would you compile this main? Based on the I'll show. Here these are the header files what I wrote, and these are the source files. Next choose washing machine, then build successfully. Yeah, first clear and build, then build successfully. We got 0 errors. The next file is created. We have to upload this X file in the PIC16F877A. That's it. Now coming into our last slide, that is conclusion. Till now, we have learned the real-time washing machine, which is simulated in the PIC16F877A and which is same as the real-time washing machine. And here we calculated the time, and we learned how to use the algorithms and how the machine is calculated and as the internal process, and we match it with the theoretical and practical experience. Here also, the PIC16Lab is a very effective virtual environment. Here we learn some tools and we apply the concepts in the embedded systems. So, washing machine simulation was very effective, informative, and also interesting to use in the lab. That yeah, it provides hands-on experience that is in theoretical and as well as in the practical knowledge. And coming to my experience, it helped me in determining the system design as well as the simulation properties of the washing machine. And that's the conclusion of the PPT, and it's also the conclusion of the internship. Here, in my opinion, I met with the goals of the internship very clearly. Then, yes, thank you, Emertxe, for giving this internship.